Congratulations, you've made it to the last chapter in the book. Chapter 16 is all about your endocrine system. In the picture there, you can see kind of the key organs that are associated with the endocrine system. So what to do? Its job really is you would equate it with hormones. So its job is to regulate the levels of hormones in your body and really like package and transport them. So they release hormones into the bloodstream, and those hormones can then influence different things like your metabolic activities, your growth, your overall development. So there's a lot of them, and they are very important. So first we're just going to kind of go through different glands that are associated with the endocrine system and talk about what, hormone they produce and what that hormone's job is. Okay. So here are the different glands, and I said organs before, but really mostly it's a gland. So we have the pituitary gland. It's about the size of a pea, and it lives at the base of your brain. And there's two parts of it. Different parts make different hormones, but the pituitary gland is really like the master gland of the endocrine system, because it's kind of like all of the hormones that the pituitary gland releases then influence or stimulate all of the other endocrine glands to then release their hormones. So it's kind of like the master controller, so to speak. You have a thyroid gland. Around that you have parathyroid glands. We have hypothalamus, adrenal. The pancreas in this case is going to play a role. And then the gonads are considered endocrine glands as well. So ovaries produce the hormone estrogen, and testicles produce the hormone testosterone. So they kind of are lumped in here too. And then we have the thymus gland. So here's kind of where all those are located. You can see the pituitary gland, as I mentioned, is at the base of the brain. And then surrounding the trachea there, you have the thyroid, which are the kind of cream-colored things here. And then these little dots on either side, those are the parathyroid. Your thymus gland lives here. The pancreas, or the islets of Langerhans that are inside of your pancreas, are here. Your adrenal gland looks like a little Hershey kiss on top of your kidneys. You have one on both sides. And then the ovaries and testes. So your book does a pretty good job in the tables on 639 and the following pages to really go through what organ and or gland, and then what hormones it makes. And your book really tells you what each hormone's specific job is to give you a little bit of guidance. So in the pituitary, you can see that it makes a ton of different hormones. So the anterior lobe is a bit bigger. It makes growth hormone, which, as you can imagine, controls the growth of your body. We have what's called adrenocorticotropic hormone, and you can see why most of these are abbreviated. That one's job is to stimulate the adrenal cortex, which is why it says adrenocortico, which we'll learn what it does separately in a minute. Thyroid stimulating hormone, go figure, stimulates the thyroid. Follicle stimulating hormone and luteinizing hormone, those two are really stimulating the gonads. So your testes and ovaries, respectively, which is why they're called gonadotropic hormones. Prolactin releasing, or also called lactogenic hormone, that's the one that females then release during pregnancy for producing milk. In the posterior lobe, we have antidiuretic hormone. So this stimulates the kidney to reabsorb water. So a diuretic in and of itself makes you lose water. So it makes you pee more. So an antidiuretic hormone's job is to kind of stimulate the kidneys to then suck up more water to get it back. Oxytocin is kind of the loving hormone. It is used by women. It can during contractions, labor, postpartum. The hypothalamus is near the pituitary gland, and its job is to release the hormones that stimulate or inhibit the release of pituitary gland hormones. So, as I said, the pituitary is kind of the master gland of the endocrine system. The hypothalamus is kind of the brain part, because it is a part of the brain portion that kind of controls the pituitary gland. So it is the tip top of the endocrine ladder. We have the thyroid, which is the largest endocrine gland, and it produces two key hormones, T3 and T4, which are thiodiroxin and thyroxin, and really you just need to know them as T3 and T4, but it helps your body metabolize. And one of the key components to this is that it requires iodine, so you do need to have iodine in your diet to have a functioning thyroid, which is why we have things like iodized salt and iodine and kind of incorporate it into some of our foods. And we'll see what happens if you don't get that iodine later on. Parathyroid are 4 tiny little nodules. You have 2 on either side of your thyroid gland, and it produces parathyroid hormone, go figure, but it then regulates calcium in your body. So the parathyroid helps control your calcium levels in your body. The islets of Langerhans, these are basically your pancreas, inside your pancreas, and they are the ones that are secreting insulin, glucagon, and other enzymes that might facilitate in the digestion process. So you're not really able to control blood sugar levels through metabolism if you do not have a functioning pancreas. Next up is the adrenal glands. So your adrenal glands are those little kidney Hershey Kiss shaped glands sitting on top of either kidney. It's kind of got some layers. So the outer portion is called the cortex and the inner portion is called the medulla. But overall, its job is to secrete a couple of hormones. One of them is cortisol, and that's one that the outer cortex layer secretes, and that's really released during stress to then increase glucose levels. So it's kind of you're really scared, you have that fight or flight response, we need to get more energy to run, historically speaking. So that's what cortisol is. Aldosterone is also secreted by the cortex, and this really controls electrolytes that are necessary for body functions, so like different mineral salts in your body. Epinephrine, also called adrenaline, also called norepinephrine, also called noradrenaline, they all mean the same thing. This is secreted by the interior portion of the adrenal gland, the medulla, and it again deals with that kind of stress, that fight or flight response. So the epinephrine increases blood pressure, heartbeat, respirations, like you're going to run. So the epinephrine piece is kind of like getting your body ready to run. The cortisol piece is kind of the giving you the energy to then sustain running. So it's kind of those stress hormones. In your book, you do have a decent picture. This one here is on page 639, but it kind of tells you the different things that the pituitary gland and the other glands are secreting and what those hormones are. It doesn't specifically tell you the function of the hormones, so I would definitely write those down. But I would also label the different glands, and when we get to the combining forms in a minute, on page 642. Okay, so now we're to the parts where we can actually put some medical terms on this. Adrenalo. So both mean specifically the adrenal gland. So if you remember way back when, adeno means gland, just any general gland. So the only difference here is the R for adrenal. And I always think of like adrenaline, so that goes for adrenal glands. Cortico is specifically for the cortex. In this particular case, it's going to usually be used in the context of the adrenal gland, but really a cortex is the outer layer of any organ, so it could potentially be used in other body systems as well. Endocrino means endocrine. Parathyroid-o, wild guess, means parathyroid. Pituitaro is pituitary. Thyroid-o and thyro also mean thyroid gland. So the good thing about these is that they sound exactly like what they are. I would say add these to your diagrams if you can. Okay, these are the ones that are going to be used a lot in terms of the disorders that we're going to come across. So acro means extremities or height. So if you think about the growth hormone that controls your growth, you can imagine how problems with that can lead to height issues. Calci, means calcium. Dipso means thirst. So one of the glands releases antidiuretic hormone, so that can lead to differing levels of thirst if you have problems. Kali means potassium, which doesn't really sound like what it is, but if you think back to the, Latin or on the periodic table, potassium's letter is K. Same thing with the next one. Natro means sodium. So if you think about on the periodic table, sodium is Na. And that's just my science self being able to remember those two that way, but it might be helpful. The suffix that we're going to hear in this chapter is drome. So drome means running. And really the time that we see this is when we see someone has a syndrome. Syn means together, S-Y-N. And then drome means running. So really a syndrome is when you have a whole bunch of symptoms that run together across people. So that's where that comes from. Okay. And here again, the book put this one together. Think of a drone running across the sky. Maybe then you can extrapolate it to drome. So which one of these would mean or have the meaning of potassium in it? Hopefully you're saying hypokalemia. The big periodic K there is an indicator. Hyponatremia would have been sodium. Okay. Diseases and disorders. So here are the ones from word parts. Not too bad. Thinking about all your suffixes again that we've learned throughout all their 15 chapters we've gone through. Megaly would be enlargement. So your endocrine gland could be enlarged. There's itis, of course, as always. A lot of these are going to have emia. If you think about the different endocrine substances that might be released into the blood, they control your sugar levels, so glucose. They control your sodium levels, your calcium levels, your potassium levels. So because of that, then you might have more or less in your blood at any given time. So for example, that's why we have hypercalcemia, hyperglycemia, hyperkalemia. You can also have a state of excessive activity. So for example, hyperparathyroidism would be a state of too much parathyroid activity. Or hyperpituitarism is a state of too much pituitary activity. Just like you can have hyper everything, you can also have hypo everything as well. So you can see that on the right hand side. And it's interesting too to note in this case, you can have hypopituitarism and hyper and hypo. Oftentimes if you're deficient, for example, in one hormone, then you might have hypopituitarism, meaning that it's one particular hormone that's an issue. But if you're deficient in all of them, then you would put the pan on the front as a prefix. So you could have panhypopituitarism, meaning all of the hormones that the pituitary is secreting are low. You can also have a tumor. So in this case, this would be a parathyroid tumor, and so on, but not too bad. So go ahead and give exercise 11 a try on page 647, and then we move to the not so fun ones of not from word parts. Okay, so as you can see on this list, a lot of them are actually eponyms. They are made from either the person who discovered it or someone else. So leading off, for example, we have Addison disease. Addison disease is a deficiency of the adrenal cortex. So that outer layer of the adrenal gland. And if we remember what the adrenal cortex is secreting, then you'll remember it is cortisol. It also does aldosterone. So it's really controlling your glucose a little bit, production, and also your electrolytes. So signs and symptoms include weakness, weight loss, hypotension, and so on. Loss of appetite. Next we have congenital hypothyroidism. So this is something that you're born with, and you have a deficiency in your thyroid. In this case, it atrophies or wastes away, and the end result is getting hypothyroidism. Because the thyroid produces a couple key hormones that are necessary for like metabolism, that hypothyroidism is characterized by having like puffy features, a large tongue, potentially dwarfism. Cushing Syndrome is attributed to excessive cortisol production. So it's kind of the opposite of Addison's disease. So Addison's disease was a deficiency of the adrenal cortex, and one of those hormones was the cortisol. Cushing's is the opposite, where you have too much production of cortisol. And so this may result from different things. So it could be the tumor talking to the adrenal cortex or so on. But this gives you kind of like a little hump on your back. It gives you moon face. It gives you hypertension instead of hypotension. So long story short, having too much or too little cortisol does have some problems. You'll notice next on the list we have two kinds of diabetes. I think the one that everybody instantly thinks of first is diabetes mellitus, DM. That's the one that involves the pancreas, the islets of Langerhans, where you're having an inability to really control your blood sugar, where you have hyperglycemia. So that's the one that we think of that is associated with insulin in the pancreas. Diabetes insipidus is a little bit different. That is specific result of the antidiuretic hormone. So you're not releasing enough diuretic hormone. So antidiuretic hormone. So that means your kidneys are not reabsorbing as much as they should. So really what that translates to is you're super thirsty all the time. You pee a lot because you're not reabsorbing the water. So I always think of insipidus like you would sip a drink because it's controlling liquids in your body. Giantism is pretty straightforward in the sense of what it results in, but it's due to overactive growth hormone being released from the pituitary. A goiter is when your thyroid gland becomes enlarged. This oftentimes could be a result of an iodine deficiency. As I mentioned, the thyroid hormones require iodine to then secrete the T3 and T4. And if they don't have that, they can't do it, so then the thyroid might become inflamed. Graves' disease This also afflicts the thyroid gland. So this case, you're making more thyroid than your body, or it's making more hormones than you need. So this would be an instance of hyperthyroidism. You can also get a goiter with that. Also exophthalmos, if we remember all the way back to the eye chapter, that's when your eyeballs kind of stick out of your head a little bit. That's Graves' disease. Ketoacidosis. This is one of the follow-up consequences of diabetes mellitus. So if it goes uncontrolled, then you can start to build up acid ketones from not breaking down fat because you don't have enough insulin. And it can eventually be lethal if left untreated. Metabolic syndrome. This is also called insulin resistance syndrome, but it's where your body is not registering insulin, or it's resistant to its effects. So that can be leading to things like obesity, hypertension, hyperglycemia. It's kind of the precursor to type 2 diabetes. So metabolic syndrome, if left untreated, can then proceed to type 2 diabetes mellitus, stroke, other things as well. Myxedema is a deficiency of specifically thyroxine, T4. So that would be a severe hypothyroidism. So you would also have puffy face, thick skin, maybe enlarged tongue, slow speech, anemic, and so on. Next up, we have pheochromocytoma. So it does have oma at the end, so you know it's a tumor. In this case, it's a tumor of the adrenal medulla, the interior portion of the adrenal gland. And usually it's non-malignant, but it does cause problems like hypertension, headaches, chest pains, abdominal pains, and so on. Tetany. So this is muscle spasms. If you think of like tetanus, it's kind of a sustained involuntary contraction, and it really has to do with the level of calcium in your blood. So if the parathyroid is not working properly and controlling calcium levels, then your muscles tend to spasm because you need calcium to contract and relax those muscle contractions. Thyroid toxicosis is the last one, and that one is caused by too many thyroid hormones. Or it's the abnormal condition, I should say, of too many thyroid hormones. So that's a ton. I would say please try exercise 14 and 15 on page 651 and after. There's some pretty good pictures just to get you using these terms, because this is one of the most missed areas on the exam, are these ones here that are not from word parts. Understanding what the disease name is and what gland is messed up for that disease, and then what hormone that is. Okay, so here we have an enlargement of the extremities. So this would be acromegaly. This is an example of Cushing syndrome. This is the same child. You can see on the left before treatment and on the right after treatment. So this is where you have too much cortisol being released from the adrenal cortex. This is an example of a goiter. It's kind of that big puffy ball in your neck region due to deficient iodine or some other reason to create a deficiency in your thyroid. Again, here's the breakdown for diabetes mellitus. You're not going to have to know the super specifics, but here they are. Type 1 is known as insulin dependent or juvenile onset. Basically, the cells themselves in the pancreas are destroyed, so they are not producing insulin in the first place to then be able to use. So those are the people that are getting insulin injections, special diets, things like that. Type 2 diabetes, which is most of the cases, is non-insulin dependent. Oftentimes this does not occur until adulthood, but this is when you start to become resistant to the effects of insulin, and then therefore it's kind of a feedback loop. You start secreting less. There are interventions, but it is interesting to note that, we have skyrocketed just in the time that, since 1985 to just 2010, and this number is probably even higher now. Okay. Moving on to surgical terms. So, thankfully, there's not a whole lot, right? I mean, if you're thinking about what you can actually do for an endocrine system problem, it's not a lot. You pretty much remove whatever it is and then put someone on what we call hormone replacement therapy to supplement whatever hormone they're not releasing anymore. So you can remove the adrenal glands, the pancreas, the parathyroid, or the thyroid. And there are none not femoid parts, so that's pretty exciting. But we do get to some diagnostic terms. So there are different things that you can do to monitor function of the the endocrine glands. So the first one is called a radioactive iodine uptake test. And this one is a nuclear medicine test measuring thyroid function. So really it's used to determine, like, the person or doctor knows you have hyperthyroidism, they're trying to identify the cause. So they give you what's called radioactive iodine, and then the thyroid uptakes that, and then you can image it. So depending on how it does that, then you can determine function that way. You can have the Systambili parathyroid scan, which is another nuclear medicine test. We kind of had that before. This is specifically
Winston Krieger to the main office, please.
Specifically looking at the parathyroid. And then you can also do sonography. So you're kind of using an ultrasound machine to look at the thyroid to kind of help determine what's going on. In the lab, there's tons of blood tests you can do. So the first one is what we call fasting blood sugar, which some of you might have had to have before. The idea is you don't eat for about 8 to 10 hours, and then they draw your blood to look at the amount of glucose in your blood. If it's high, then that is an indicator for diabetes mellitus. A fine needle aspiration is where they use a little hollow needle, similar to what we had with a bone marrow aspiration. This one just uses a tiny little thin needle to obtain a biopsy sample from the thyroid, for example, basically to just assess whether it's cancerous or not. Next, we have glycosylated hemoglobin. This is a blood test to diagnose diabetes and really monitor the treatment of diabetes. This one is interesting because it's able to indicate blood sugar levels over the past 3 months, because that's how long red blood cells live typically, about 120 days. And so they can kind of look at the amount of glycosylation on a sample and give a good historical picture of your sugar levels over the past 3 months. So that's a little bit different than the fasting blood sugar, which just kind of gives a real-time picture. Thyroid stimulating hormone test. So that's TSH test is measuring the levels of TSH, the hormone, just to give an idea of hypothyroidism. And then thyroxine level is just the blood test to measure that particular hormone, again, to really look at hyperthyroidism or hypothyroidism, depending on what your levels are. So please go ahead and try exercise 22. It's matching, so that you can kind of get an idea of what the test is and what it's measuring. We're almost there. Cruising right along. Here are the complementary terms. Again, these ones are all from word parts if you remember our suffixes. Plasia means excessive development. So we have hyperplasia for excessive development, in this case of the adrenal cortex. Pathy is disease. AL means pertaining to, so cortical would be pertaining to the cortex. Oid means resembling, not pertaining to. In this case, an endocrinologist is the person who studies and treats diseases of this system. They study endocrinology. As we had seen previously, if you have normal levels of something, not everybody has a disease in everything, you would use EU as a prefix. So if you have euglycemia, you have normal levels of blood sugar. If you have euthyroid, that means you have or are resembling a normal thyroid function anyway. Glycemia is just the level of sugar, so you can have euglycemia, hyper or hypo. Polydipsia is when you're very thirsty, so that constant feeling of being thirsty just means many thirsts, kind of, so that's what polydipsia is. And syndrome, I'd already mentioned previously, which is symptoms running together. Exercise 27 is going to cover all of those words. So give that a try, and then we're just going to cover the couple not from word parts. Exophthalmos is really reviewing from chapter 12 in the eye. So it's that like bulging out of your head eye experience. There's also a different picture of it on page 659 in your book. Hormone, which is what we've been talking about this whole time, is really just a chemical substance that's carried by the blood to its target. So it's different than like a neurotransmitter or something else. It's specifically secreted into the blood. And then we have incretins. Incretins is a group of hormones that your gastrointestinal system releases to stimulate the release of insulin. So it's kind of like a precursor to the release of insulin by the pancreas. So if you're having problems with this, that might also lead to insulin problems and therefore diabetes problems. An isthmus is a narrow strip of tissue that connects two larger parts. So if you think like geographically, you could have a land isthmus if there's like a tiny bridge connecting two areas. In this case, here is an isthmus where you have two wings, so to speak, of the thyroid gland, and then there's a narrower connection between. That's called an isthmus. And then metabolism, it's a pretty common word, but what it really means is the sum total of all of the different chemical processes that take place in your body. So one of those would be breaking down food, but there's many, many, many more. So holistically and collectively, we're calling all of those chemical processes metabolism. Okay, so your body covers tons of different syndromes. This is just to draw your attention to it because there's diseases and then there's syndromes. So it is hit in many, many different chapters as more of an FYI. All right, so hypothyroidism can be detected by what? If you think that the thyroid controls the T3 and T4 production, or if anything, just thyroid starts with a T, the answer is B, thyroid stimulating hormone. And then fasting blood sugar is a little bit different because that is going to measure sugar levels in the blood. Okay, so at the very, very end, as always, we have all of our abbreviations, which are not that bad. It's mostly in reference to the different hormones that we are talking about throughout and or some of the tests that we're talking throughout. So you can put these into practice in exercise 33 on page 661. I'm giving you a couple different review options here. I'm just going to kind of skip through in this case because I did want to draw your attention again, as always, to the end where it ties everything together, put some words in context. In this case, on page 665, the quiz. And at this point, you've successfully made it through the entire textbook. All, 660 plus pages of knowledge. So congratulations.